All right, so we're talking about user-defined functions, which we do introduce in 1181, but we don't spend much time on it. It's important to understand you have already been using functions. Okay, linspace, sine, plot, those are all functions. So when you see something like this, you're calling a function. A user-defined function is called the same way. It's just that this function doesn't exist in MATLAB, so you have to create it. Okay. So if there's some operation that you do routinely, or that you're going to do repeatedly in your program, instead of copying and pasting that code each time, you put it in a function and then you call the function repeatedly. Okay. So, for example, back in application 1, when you were converting numbers from binary to decimal, well, since we hadn't covered functions yet, we also hadn't even covered loops yet, you just copied and pasted the code. But that's a bad practice in general, because what if it turns out you did it wrong? Well, then you have to go fix it every place you did it. Whereas if it was in a function, you would only have to fix it once. All right, so let's say there's some manipulation that you do on data. I'm just going to call it manipulate. So you make a function called manipulate, and then you can call it from your main program just the way you call any other function. All right, so where do you put a function? Now, there are different ways of doing it, which we'll cover later. But for right now, here's how we want you to do it. Put each function in a separate file, and the name of that file will be the same as the name of the function. All right, so in this example, you would have a file called manipulate.m. And you either put it in your top MATLAB folder, or what probably is better, put it in the subfolder where you're putting this program. Okay, so as your programs get more complex, you may have several files, a main script, and then 2 or 3 functions, each in a separate file. Just put all those files in the same folder, and then you won't have any problems. All right, so let's say this program has some functions, and I'm just calling them function 1, function 2, function 3. But of course, you want to give a function a name that describes what it does. So they would be in separate files called function1.m, function2.m, function 3, and function 4. Right? Now, having done that, you can actually call these functions from different programs. Now, you might have program 1 that uses functions 1, 2, and 3. And so it's calling those functions that are in external files. And then you make a different program called program 2, and it happens to use that same function, function 2, and also uses another function called function 4. All right. So this is the advantage of putting them in separate files. You can call them, or at least one advantage, but you can call them from different programs. All right, so if there's some common operation, which I'm like function 2 here, that you use in many different programs, you only have to have it once. Right? You write that function once, put it in a file in your top level MATLAB folder, and different programs can call it. And not only that, but functions could call each other. People seem to have a hard time with this, but function 3 could call function 2. The only thing that you typically don't want to do, you don't want the function calling the main program. It'll work, but it's a bad practice. It'll cause problems. Okay. And of course, a function name can be similar to a variable name, I think up to 63 characters, letters and numbers, and the underscore, and begins with a letter. And just like a variable name, it's case sensitive. Okay, so you have to decide, do I want these to be capitalized or not? But once you capitalize them, then you have to be consistent. And of course, you don't want to use a name that's already taken by a MATLAB built-in function, like sine or log or exp, because that will kind of override the built-in function. And so unless you have a better way of doing the sine than the standard way of doing it, you don't want to call your function sine. All right, so here's what a function definition looks like. First of all, it always begins with the word function. Never put any code at least for now, with the way we're doing it right now, do not put any code before the word function. All right, it won't work. You can put comments, but you cannot put any code before the function line. All right. The name of the function goes here on the right of the equal sign. Now, of course, the way a function works, you pass it information, just like with built-in functions. Okay, these numbers that I'm passing to the function, these are arguments, input arguments. And then the function returns something to me. Okay. So I don't have to know anything about how the linspace function works. All I have to know is, what do I pass to it? And then what does it give me in return? All right, so the inputs go in parentheses here. And the outputs go to the left of the equal sign there. And there can be more than one. But in this simple example, we only have one output. All right, and then whatever code, whatever this function does, goes here. So that's what this is, just represents some block of code. But the key thing is, this output argument has to get assigned to a value somewhere. All right, so somewhere inside the body of this function, and usually it's at the end, that output argument, which is just a variable, gets assigned to some value. All right, so if you've programmed in other languages, it might seem like there's something missing here because there's no return statement. MATLAB, you don't need a return statement. Okay, in other languages, that's how you tell the function what to return. But in MATLAB, all you have to do, you define the output argument here, and then somewhere in the body of the function, you have to assign it a value. Right? And then the function should end with the word end. All right, so here's a real basic example of a function. The name of the function, oops, I got ahead of myself here, but the name of the function is just SQR. This is a function that's going to take the square of a number as opposed to the square root. Its input argument is x. And you can see the way the function is defined, I put the dot here. So x could be an array, or it could be a scalar. And notice there's no way of telling MATLAB here. There's nothing you have to do to tell it that it's an array. You can just call this same function. X can either be an array or a scalar. It'll still work. Okay, so people get hung up on that. How do I tell it that X is an array? You don't. You just assume it's an array when you write the code. And then when you call it, you pass it an array. That's all you have to do. All right, so somewhere inside the block of code, this output argument x sqrd has to get defined. And so this function only consists of one line. Just calculating x sqrd is x squared. All right, so the input argument is x. The output argument is x underscore sqrd. The name of the function is just sqr. So it should be in a file called sqr.m. All right, any question about that? Other than, why would you bother writing a function that's only one line? You probably wouldn't. It's just, we're just using it as a really simple example. All right, here's an illustration of how calling a function works. Right, so in your main program, which we'll call the script, and so what we've done up to this point, just sort of linear code, we call that a script. You can call the function. And so just like you're calling a built-in function. If you wanted to call the square root function, you would have sqrt of 2. Well, now that we've defined this sqr function, you call it the same way. And you pass it a value. Okay, now here I'm just passing it as a number. I could also have put that value into a variable and then pass the variable. But ultimately, all that's really getting passed to the function is the value that's put here. All right, so that number 2 gets passed to the function through its input argument. And so as far as the function is concerned, x now has the value 2. And so the input argument is just a variable, place where MATLAB stores this value that was passed to it. Does this calculation, stores the result in another variable called x, sqrd. And, I really should have put this arrow coming from here maybe, but maybe it should have, whoops, didn't do what I wanted. There we go. Maybe I really should have shown it maybe coming from here, from the output argument, okay, because that's how values get passed back to the caller, to the main program. Okay. But again, all it's sending back is a number. It's sending back the number 4. Right? And what's the main program do with it? Well, it stores it in its own variable called y. All right, so after this, we could do a disp or fprintf of y, and it would print out the number 4. Or you can also call a function just from the command window. Again, just like you could do sqrt of 2, now we can do sqr of 2, and it'll display the answer. And once again, I got ahead of myself here. These answers, well, I guess I messed this up, but the answers weren't supposed to be displayed yet. But suppose the next line in the script file is dispx. And so right here, I'm sorry, in the script file, we put disp x. What happens? Well, the answer unfortunately is already displayed, error, but why is it an error? The answer is because this variable x is only defined within the function. The terminology for that is the scope of the variable is only within this function. So once this function is done running, that variable gets erased from memory. It's not there anymore. So the main program does not know anything about the variable x or the variable x sqrd. Those only exist within the function. All right. And similarly, if we try to do a disp of x sqrd, we'll get an error because we're not inside the function anymore. Those variables don't even exist anymore. Now, on the other hand, if we put a disp x inside the function, then we'll see the value of x, which is 2. Okay. So as long as that function is running, those variables are defined. As soon as the function is done, they're erased. All right, here's another example. Let's say we want to make a function to calculate body mass index given a height and weight. Okay, so here's a function with 2 inputs now. So given the height and weight, we calculate that, put it in this variable BMI value. That's the output argument. So that's what gets sent back to the caller. All right, so what are the input arguments? Well, height and weight. What's the output argument? BMI value. What's the name of the function? That's the name of the function, BMI. And it is case sensitive. So it's all in caps. So when you call it, you have to put it in caps. So it'll be in a file called bmi.m. Okay. Now, when you call the function, you're passing 2 values to it, height and weight. If you look at that, it's not obvious which one is which. So how does the function know? Well, it's just by order, right? The first number you give it goes into the first argument. The second number goes into the second argument. Okay. So then the function runs, it calculates this value and sends it back to the caller. And we might have stored it in another variable, or we may have just displayed it to the command window. But that's the result. All right, so somebody asked the question. You'll notice with a lot of the MATLAB built-in functions, you can give it different numbers of input arguments. How does that work? Well, that's an advanced technique which we'll cover in a week or 2. Okay, that's just a special technique to allow a function to have multiple input arguments. All right, but the way this function is defined, it has to have these two input arguments, precisely two input arguments. Okay. If you want it to be more flexible, you have to use a special technique for that. All right, here's another example. So this is the same thing, calculating BMI, but now we're making it a little more elaborate. Not only is it going to return the BMI value, it's also going to return the person's weight classification: underweight, normal, overweight, or obese. And I did this a clever way. Okay, so we haven't covered if statements yet, so I wanted to show you can do this without an if statement. All right, so you pass it the height and weight just like before, calculates the BMI value just like before. Okay, that value gets passed as one output. But then we also determine the classification. Okay, so you see I've got a long logical expression here. And this is that technique I showed you last time, where you have different relational operators that are all complementary. Only one of them is true at a time. Therefore, only one of these terms is non-zero. And the way it's set up here, this will evaluate to 1, 2, 3, or 4, depending on which one of these is true. And then I use that as an index to pick out one of the strings from this string array weight classes. So let's say BMI value happens to come out to be 20. Okay, let's say this evaluates to 20. Well, this is false. This one is true. And these two are false. All right, so since this one is true, it evaluates to 1. We multiply that by 2, and that's what we get here. So altogether, this evaluates to 2. And then we use that as an index into this array. We pick out the second value, which is normal. All right, so that's what will get returned in this second output argument classification. All right, so you've got two output arguments, BMI value and classification. Now, when you call it, since you now have two things coming back, you need to give it two variables to store those results in. Okay, so you've seen this before, like when we used the min function, when we wanted it to give us both the min value and the index. You put the two variables in square brackets. Okay, and again, it lines them up just by order. So whatever BMI value was, that'll go into that variable V. In classification, we'll go into this variable C. And an important point, these names can be anything you want. They do not have to match the names that were used in the function. There are two different sets of variables. Okay, the function has its variables. The main program has its variables. The names do not have to match. They're just matched up by order. Okay. All right, so when you run this, well, if you give it these two values, then V is going to come out to be 27.1219, and C is going to be overweight. Okay. All right, any questions about how that works? Very good. Because if you got that concept, oops, if you can follow this, you're in very good shape for using functions. Okay. Okay, so weight classes is just a string array, right? It's got these 4 strings in it. And what I'm doing down here, I'm making a logical expression, which is going to, one of these terms is going to be true. That is, one of these expressions is going to be true. So this all is going to evaluate to either 1, 2, 3, or 4. And it's going to pick out the corresponding string.